Hi guys, so we're just continuing on from the power rule. So make sure that you've seen the first video on the power rule where we covered the first two examples. So we're going to apply the same rule where we're going to clean up the function first to prepare it for the power rule. So if you'll notice, x as well as its exponent is in the denominator. However, not only is x in the denominator, but the exponent belongs to now 2n x because it's in parentheses. So we need to move everything up to the numerator, or I'm going to leave two options here, or you can just give each one its own denominator of 3, because again, the 3 belongs to the 2 and the x. So meaning I can clean it up this way first. Before I even start the power rule to find the derivative, I have 5 over 2 to the third power is 8, x to the third power. I'm only going to move the x to the third power because it's in the denominator. I need it in the numerator in order to apply the power rule. So think of this as 5 over 8, just to make it easier when we apply the power rule. And then to move the x to the third power from the denominator to the numerator, I change the sign of the exponent. So now that it's set up, I'm ready to just apply the power rule. So this will be h prime of x equals, I'm multiplying the exponent times the coefficient. So I'm going to take a sidebar here. If I multiply 5 over 8 times negative 3, the fraction form of negative 3 is negative 3 over 1. To multiply fractions, you go straight across, and that'll give you negative 15 over 8. So negative 15 over 8, and then x to the, remember we always take 1 away from the power to determine the derivative using the power rule. So if I take negative 3 minus 1, signs match, so I add, and I take the sign of the bigger number, which is 3, and it's negative. So this is my derivative. However, I have to clean it up a little bit because originally notice how the function was not written with a negative exponent, so we don't leave that there as well. So negative 15 over 8, again, remember those two are fine. Nothing's wrong with them. They don't have a negative power. So the only thing I need to move, which is, remember the fraction form of any constant or any number by itself or anything, is just over 1. I need to move this from the numerator to the denominator, and it will change the sign of the exponent, and that's it. All right. Now, just one thing to note for this, I shouldn't have even left so much space for this one problem. Anytime you're dealing with a constant, the derivative of a constant is 0. Well, why is that? Because technically, if I'm taking x, which there's no x here, this is technically x to the 0 power. So I'm just going to bring this down here. If I were to take 5x to the 0 power and apply the power rule, 0 times 5 is 0. And 0 times anything, doesn't matter what the next x is, it will be 0. So just, you don't have to apply the power rule. I just kind of wanted to note that. And I'm just going to go back to the original paper that I showed you. Remember from the first power rule video, note that the derivative of any constant is equal to 0. So the rules are there in case you need. All right, guys, I hope this helps.